Dia. My name is Steve Grimes, and I first want to thank the Congress of Clinical Engineering and Healthcare Technology Assessment for this opportunity to speak with you today on the subject of the need for bold changes in the clinical engineering and healthcare technology management professions. This is a short biography. I won't go into it in detail other than to tell you that I'm a clinical engineer with 40 years in experience, and I've managed, in that time, I've managed clinical engineering services in major medical centers, have serviced as a chief technology officer for a major independent service organization, and I'm now a consultant who also teaches cybersecurity risk management part-time to graduate clinical engineering students at the University of Connecticut. I've been active in our professional community, having been a past president of the American College of Clinical Engineering, and I've been very active in various capacities with both AMI and HIMSS. So this is what I'll be covering in this presentation. First, I'll attempt to show how clinical engineering and healthcare technology management support services must take into consideration the range and the rate of evolution of new technologies. Next, I'll speak on the evolution of medical technologies over the past 30 to 50 years. I will then discuss how gaps have grown between new technologies and the clinical engineering and healthcare technology management professional knowledge, skills, and abilities necessary to support these new technologies. I'll give some examples of the new clinical engineering and HTM, healthcare technology management support services required to support new technologies, and also give some examples of the new knowledge, skills, and abilities required of clinical engineering and HTM professionals. And finally, I'll give a brief summary of the points I've covered during the session. Let me begin by stating what I believe should be an obvious fact. Healthcare technology management services and clinical engineering and healthcare technology management roles must be a function of technology. That means that new medical technology, as new medical technology evolves, the nature of clinical engineering and healthcare technology management support services, including support for professional roles, must also evolve to remain relevant. From a technology standpoint, the principal drivers in the past and the near future include increasing convergence of technologies, particularly those related to medical information and telecommunications, and increasing technology complexity. Today we have not just technical systems, but the evolution of systems. Medical technologies, like so many other technologies we deal with today, they've become smarter and more software-based. And the modes and the venues for healthcare delivery are changing. We'll continue to see more telehealth and home care. What does this mean for those who support those technologies, that is, the clinical engineering and healthcare technology management professionals? It means their roles must evolve and change corresponding to the evolution in the technology. We need to recognize that old approaches to support of traditional technologies don't necessarily work for new technologies. The rate of change means that the clinical engineering and healthcare technology management community must prepare for continuous education if they're going to stay relevant. So this graphic is meant to summarize the previous points made. With new technology, there is the need for new services and tools, which in turn require new support roles to develop new knowledge, skills, and abilities. Existing clinical engineering professionals should consider that their future viability and their success is not certain. I suspect that the blacksmiths once thought that there always be a need for someone of their capabilities. The truth is that there are few certainties, and if we as a profession don't evolve, we die and are replaced by others better capable of evolution. This chart is meant to illustrate our challenge. It shows our relevance on the vertical axis and time along the horizontal axis. This part shows how we've evolved the old clinical engineering, healthcare technology management paradigm, and how we've come and are passing what's considered a strategic inflection point. If we keep this up with the status quo in our profession and aren't prepared to make considerable change, we lose relevance and are doomed to failure. If we make the necessary changes and embrace a new, more relevant clinical engineering HTM paradigm, we can realize success. But we only have a limited time, a limited opportunity for change before the necessary course correction becomes impossible. So we'll now consider the evolution of medical technology over the last 30 to 50 years. For much of the last 30 to 50 years, technology consisted of relatively simple, discrete, and unconnected devices. These were often single-function diagnostic or therapeutic devices. Clinical engineering support services were traditional and basic, including safety services, planned and corrective maintenance, compliance, and equipment management, including purchasing and replacement advice. Services provided by engineers and engineering technicians. Over the past 30 years, the evolution of increasingly computerized and connected systems has led to the evolution of hybrid systems, that is, systems that included not only medical technology but also incorporated elements and information and telecommunications technologies. Because of the overlap of clinical engineering and healthcare technology management and IT support services is often not seamless, this poses a particular challenge because it often is not clear whether a particular problem or issue is related to medical technology elements or of a system, or related instead to information technology or telecommunications technology. It's also a new challenge for clinicians who are having technical issues because it's not often and not clear whether they should be contacting clinical engineering or healthcare technology management or IT for assistance. And frankly, that's not a choice we should be asking clinicians to make. Over the last 30 years, healthcare technology has grown considerably more complex. As we move into the near future, medical technologies continues to evolve. Most medical device manufacturers today will admit that they're becoming primarily software developers. Whenever possible, more medical data processing and storage will be moving from local devices and networks up into the cloud. The reason for this migration is the potential for greater efficiency, increased availability to users regardless of their location, and better management and better security and backup. After moving data processing and storage to the cloud, the remaining hardware for many medical devices will be like slim clients in IT. It will largely be diagnostic sensors and therapeutic actuators. Over the past 30 years, healthcare technology has greatly gained considerable capabilities and features. We have diagnostic devices that are having information, sharing information shared with therapeutic devices. For example, a monitor could detect a patient's drop in heart rate and provide feedback to an infusion pump to reduce the flow of a sedative. Increasingly, medical systems are populating electronic records and the patient data that can be analyzed to pinpoint a patient's diagnosis and develop a treatment plan. Over the past 30 years, we've begun to see a move to more diverse healthcare delivery modes and venues. We're moving more rapidly to telehealth, most recently driven by the COVID pandemic. We're also developing and deploying new technologies that will enable us to deliver care at home, at work, at school, and on the go. One particular interesting aspect of the COVID pandemic is that, among other things, it's accelerated many trends that have already existed in our society, including trends in healthcare delivery. The pandemic has accelerated the move toward telemedicine. Many of the previous impediments, particularly the legal ones, have largely been removed. Another accelerated trend has been increased improvements in remote monitoring and examination capabilities, home treatment using new technologies, and robotics. Improvements in the remote device management, including remote updates, patch applications, and activity logs, and troubleshooting are also there. In this scenario pictured here, an engineering technician is servicing a medical device. Traditionally, field engineering technicians have remotely accessed service experts like the manufacturer over the phone to obtain service assistance. Increasingly, organizations are using teleservicing via the internet to conduct remote diagnostics and troubleshooting. This also includes software updates and patching via remote access. We're beginning to see the use of advanced technical support between the remote service expert and the field engineering technician using augmented reality, where the field engineering technician becomes the eyes and hands of the remote service support. Another trend accelerated by the COVID pandemic has been colleges and university education, operations and technical training, conferences and professional support are now all being transformed online to become available on demand from any location with an internet connection. In the next section, we'll examine how the changes we've been discussing have all contributed to gaps between the knowledge, skills, and abilities of the existing clinical engineering and healthcare technology management professionals and the new medical technology requiring support. Examples of some of the technology driving the future of medical devices include robotics, 3D imaging and printing, telemedicine and remote monitoring, micro and nanotechnologies, individualized medicine including genomics, connected systems of systems, and cloud-based solutions including the Internet of Medical Things and 5G, clinical decision support systems and other expert systems, and the use of artificial intelligence and augmented reality. Connected technologies and nanotechnologies will enable us to diagnose and treat areas we previously could not access because of distance and other physical limitations. 3D printing and genomics will enable us to diagnose and customize much more effectively these treatments. And clinical decision support systems and artificial intelligence will allow us to access and accurately apply a vast array of knowledge in ways not previously possible for any one group of practitioners. In this chart, we'll look at the evolution of healthcare technology, its increasing capability and complexity over time. We compare the evolution of healthcare technology to the trajectory of clinical engineering and healthcare technology management evolution. Up to today, clinical engineering and healthcare technology management have largely been on track with the technology evolution. However, the technology evolution is now becoming a hockey stick where the curve rapidly accelerates as time progresses. The current trajectory of clinical engineering and healthcare technology management services is woefully inadequate to meet the needs of the healthcare technology of tomorrow. We need to do a clinical engineering and healthcare technology management trajectory reset, a rapid course change, if we're to have any hope of being relevant and providing adequate support in the future. In the next section, we'll look at examples of new clinical engineering and healthcare technology management support services required for new technologies. Examples of traditional clinical engineering and healthcare technology management support services included safety management, including operational safety, cleaning and storage, planned maintenance, corrective maintenance, including installation, calibration, compliance, and equipment management, doing things like the inventory. Note that now we're seeing we see here some examples of advanced healthcare technology management support services necessary to support advanced technologies. And these include things like life cycle and asset management involved in the acquisition, support, and replacement and retirement of technologies, quality management systems, systems engineering, dealing with the managing of systems, including integration, cybersecurity management, risk management, analytics, including the analysis of usage, incidents, and problems, incident and problem management, project management, and specialized technologies, including robotics, 3D imaging and printing, and artificial intelligence software. Examples of the necessary clinical engineering and healthcare technology management professional roles and the new knowledge, skills, and abilities required for these professionals are covered in the next few slides. Today, technology support service paradigm requires three types of professionals. These include engineers, technology managers, and engineering technicians. These three roles represent the three legs of the technology support services stool. When specifically considering healthcare technology support, these three roles become clinical engineering, healthcare technology management, managers, and biomedical engineering technicians. In this Venn diagram, we see the three technology support roles defined where engineers are responsible for program design, creation, production, plan development, analysis, and modifications. Engineering technicians are responsible for applying, implementing, conducting, measuring, and testing. And technology managers are responsible for planning, managing, and achieving program goals. In this Venn diagram, we see specific responsibilities in the three healthcare technology support roles for clinical engineers, biomedical engineering technicians, and healthcare technology support managers. The new healthcare technologies require clinical engineering and healthcare technology management professionals acquire the knowledge, the skills, and the abilities to, in the following areas. Strategic planning, including planning for equipment acquisition, replacement, and updates, project management, vendor and contracts management, data analytics, evaluation of the safety, effectiveness, and resilience of newly evolved technologies, configuration and integration of systems, the application of quality management systems for medical technology services, risk and security management services, incident and problem management, continuity management, and other specialized services, including things like robotics, services for robotics, 3D imaging and printing, and artificial intelligence software. As clinical engineering and healthcare technology managements evolve to more effective support of healthcare technologies, hybrid technologies, they will have to learn to collaborate with more effectively with information technology services. This will require that IT and clinical engineering and healthcare technology management infrastructures that are shown here as the two pillars supporting healthcare technologies will require that they collaborate using common best practices. Examples of these common best practices are service level management, change, release, and configuration management, an integrated service desk, incident and problem management, security and risk management, availability and continuity management. Healthcare organizations should consider adopting and adapting information technology management standards like ISO IEC 20000 or ITIL in developing their medical and information technology service management guidelines. For many in the workforce, particularly in the technology-related businesses like ours, education will not be something you will ever complete. The technology we support is evolving at such a rate that what you learn today will likely be quite different than what you need to know to do in your job 5 years from now. Obtaining a degree will no longer be sufficient. Continuous education, that is university, college, and certificate programs and industry programs, has got to become part of your job if you're to remain relevant in healthcare technology management. It's crucial that as the technology evolves, clinical engineering and healthcare technology management professionals acquire new skills and expertise when previous skills and expertise become obsolete and irrelevant. This graphic illustrates the various career paths for clinical engineers, biomedical engineering technicians, and healthcare technology managers. Starting with the clinical engineer, they typically can advance to a systems specialist role and then on to a technical subject matter expert, that is systems integration or cybersecurity, for example. Or they can focus on management, becoming a supervisor, and eventually moving into healthcare technology management, and perhaps at some point the C-suite, becoming the organization's chief technology officer or CTO. For biomedical engineering technicians, they can progress to more advanced levels and yet more advanced, eventually becoming a technical expert and systems specialist. Or they may become a supervisor, perhaps moving into healthcare technology management and maybe even the C-suite. Biomedical engineering technicians may also elect to return to school and obtain an engineering degree. Healthcare technology management professionals may progress into healthcare technology management and possibly into the C-suite. Biomedical engineering technicians may also return to school and obtain a technology management degree. Information technology professionals may also evolve into the C-suite executives, or they may move into the biomedical engineering profession, or biomedical engineering technicians may move into the information technology profession. In this section, I'll summarize key points. In the future, medical and information technology will continue to evolve in ways that blur our old concepts. Examples of this include the question of when is a device a computer and when is it software or a medical device. Medical device equipment manufacturers are increasingly focused on developing software, some of which will be hardware platform agnostic. The future of clinical data analysis and storage is in the cloud. Also, rapid technology innovations will place increasing burdens on regulators who are challenged to regulate effectively without stifling competition. Healthcare providers who may be financially constrained but who want new technology in order to be effective and compete for new business. And existing clinical engineering and healthcare technology management and IT infrastructures that must collaborate, acquire new tools, and learn to prioritize in order to address greatest risks if they hope to support new technologies. This is a brief summary of the steps clinical engineering and healthcare technology management community needs to consider in their course reset. Clinical engineering and IT need to change their current trajectories if they are going to be able to be in a position to support converging and evolving technologies. They need to consider how to redefine their roles that were originally defined decades ago so that they are now relevant to today and tomorrow's needs. They need to identify education and skills that will be necessary to move into those redefined roles. They need to work with the industry to define new guides and standards that facilitate collaboration between support services and ensure future services meet the needs. And they need to identify and work with other stakeholders and their organizations to further define effective roles and relationships. This presentation was based on an article that I wrote in Amy's Biomedical Instrumentation and Technology, the VINT journal. The article is available for download at the URL that I've listed here on this slide. And with that, I will be willing to, or be happy to take any questions and see if there's any discussion. Obrigado.